In this video, we are going to discuss what are the characteristic equation for the different flip-flops. First, we can take SR flip-flop. So in SR flip-flop, we have three inputs, that is S, R, and Qn, that is the present state. So next state, that is Qn plus 1, depends on the inputs S, R, and Qn, that is the previous state. So to find out the equation for Qn plus 1, we can throw the KMF for SR flip-flop. So you can take three inputs. Here you can take it as RS as the input. Here you can take it as Qn. So Qn have value 0 or either 0 or 1. For SR can have 0, 0, 0, 1, 1, 1 or 1, 0. Now when the RS is 0, 0 and RS is 0, 0, Qn plus 1 is Qn. So whatever be the value of Qn, that will be the Qn plus 1. So when 0, 0, you can mark here 1 because here Qn is 1. Next, when R and S are 0, 1, we know that irrespective of the previous state, the output will be 1. So 0, 1, the output will be 1. Now, when 1, 0 occurs, is 1, 0, irrespective of the previous state, the output will be 0. Now, when 1, 1 occurs, this is an invalid state, so you can mark it as X. Now, if you find out the expression for this, you can group these four as one group and these two as another group. So the expression will be Qn plus 1 is equal to here 0, 1, here 1, 1. So R has the value 0 and 1. So R get cancelled. So it will be S. Then for this group here Qn is 0, in this case is 1. So S plus. For this one we have second group, we have R and S 0, 0, 0, 1. So R is 0, so R complement. S is 0 and 1, so that get cancelled. Then Qn is 1, so Qn. So your expression for Qn plus 1 is this. Qn plus 1 is equal to S plus R complement Qn. That is the characteristic equation for the SR flip-flop. Next is D flip-flop. So for D flip-flop, we have one input, that is D, and your final output Qn plus 1 depends on D as well as Qn, that is the previous state. So again we can draw the K-map for the D flip-flop. So here only two variables. The first one is D, the second one is Qn. So D can have value 0 or 1. Similarly, Qn can have value 0 or 1. Now when D is 0, we know that for irrespective of your Qn, that is the previous state, the output is 0. And similarly, when D is 1, irrespective of the previous state, the output is 1. So when D is 1, output will be 1. So if you group it, it will be Qn plus 1 will be equal to D. So the next state will be equal to the input that we apply in the D terminal. Next is JK flip-flop. For JK flip-flop, we have two inputs as J and K, and the output Qn plus 1 depends on J and K as well as Qn, so the previous state. So here we have three input variables and one output variable. So if you draw the K-map for this, you can take J and K as a variable here. Here you can take Qn as a variable. Jk we can have combination 0 0, 0 1, 1 1 and 1 0, 0 and this one is 1. Now when the Jk value is 0 0, the output Qn plus 1 is Qn. So whatever be the value of Qn, that will appear as the Qn plus 1. So here it is 1, here it will be 0. Now when J, K is 0 1, irrespective of the previous state, you will get a 0 value. Similarly, when J and K is 1 0, irrespective of the previous state, you will get 1 as the output. So here it will be 1 1. Now when 1 1 condition occurs for the J and K, the output, that is Qn plus 1, is the complement of the previous state output. So when 1 1 occur, here it is 0, so it will be complement of that one, that is 1. Then here it is 1, so that's complement of that, that is 0. So this is the K-map, so we can group it. So if we group these two, and we can group these two. So if you write the expression, you will get Qn plus 1 is equal to, the expression for this one is J Qn complement plus expression for this group is in this group J is 0 and 1, K is its complementary, that is 0, then Qn has the value n. So this is the expression for Qn plus 1 for the JK flip-flop. Next is T flip-flop or toggle flip-flop. So in toggle flip-flop, we have one input terminal as T, then second input variable is Qn. So Qn plus 1 depends on these two. So if you draw the K-map, you can take one of the input as T and this input as Qn. T can have value T 0 and T equal to 1. For Qn also you can have 0 or 1. So when T is equal to 0, you will get Qn as the output. That means whatever be the previous state, you will get the same state as the next state. So Qn plus 1 is 1 when Qn is 1, and Qn plus 1 is 0 when Qn is 0. Similarly, when T is equal to 1, you will get the toggle, that is the complementary of the, your state. So when T is equal to 1, you will get the complementary of the Qn. Here it will be 1, here it will be 0. So if you group it as one group, this is the second group. So you can write Qn plus 1 is equal to, for this group, you can write that is equal to T Qn complement plus, for this you can write that is equal to T complement Qn. So this is the expression for the T flip. Now in this slide, it is the summary of different flip-flops. Here are the two table, that is characteristics table or truth table. What for a particular input combination, what is the output that is given in the characteristic table. Now excitation table means what are the input that you have to give for a particular change of the output. Okay, first we can take SR flip-flop. Here this is the simple used for SR flip-flop. This is a true table, that is when S is equal to 0, R is equal to 0, Qn plus 1, that is next it is Q, then 0 1 it is 0 1 0 it is 1, and 1 1 it is an invalid state. So this expression we already obtained using CAMAP. Now excitation table, that means suppose if your current output of your SR flip-flop is 0 and next output that you require is 0, you have to give an input as 0 and x. X means you can have a 0 or 1. So if you want to have a change from 0 to 0 in the next clock, that is current state is Q, next state you require is 0. Current state is 0, next state you require is 0, then S should be 0 and R can have 0 or 1. Similarly, you can take this condition, that is if the current output is 1, in the next clock you need, or the next state required is 0, you have to give S as 0 and R as 1 before giving the next clock pulse. So excitation table means for the particular change of the output, what are the input combination that you must give? That is known as the excitation table. So the second one, it is the JK flip-flop. This is a simple use. This is the characteristics table. This is the expression for JK flip-flop, and this one is the excitation table. And this is the D flip-flop. It's simple and it's a characteristics table or truth table. This is the expression and this is the excitation table that you have to for the D flip-flop. Now for T flip-flop, this is a simple use. So this is the characteristics table and this is the expression for the output, and this is the characteristics excitation table.